Today we are talking about binomial distributions. So it's another kind of probability distribution with its own features. So what is a binomial distribution? A distribution with independent trials whose outcomes are either success or failure. Okay, so the random variable is the number of successes in a given number of trials. So we have a number of trials. How many successes do we have? That's our random variable. So it's how the question is formed. So if I have 4 red marbles and 3 blue marbles, if you randomly select one marble and repeat 4 times, assume you replace the marble. So there's replacement. So everything is independent. What is the probability that you select a red marble twice? So what's the probability that you select a red marble twice? So we're just going to explore it first by drawing a probability tree. So we have red and blue. Each time we can have red or blue. Okay? And then we count outcomes. All right? For each path, count the number of successes. What's a success defined as? Picking red. So there's 4 reds here. 1, 2, 3, 4. This path has 3 reds, right? 3. Whoops. And this path has, well, we'll just count them all, right? So this has 0 reds, okay? And this has, we'll just count them to make sure that has 1 and 0. That has blue red, so there's 1, red, that's 2, right? This one starts with 1, 2, 3, 1, 2, that's it, 1, 2, and 1, etc., etc. So how many paths have 4 successes? So we count how many paths have 4 successes. 1. How many paths have 3 successes? We're going to do the probability distribution. So how many paths? We have 4. How many paths have 2 successes? Well, 6 of them. And how many paths have 1 success? Again, there's 4. And how many paths have 0 successes? Well, there's only 1 0. It's over there. Now, if you look at these numbers, you may see a pattern here. And if you remember Pascal's triangle, 1, 3, 1, 3, right? And 1, 2, 1. Oops. And 1, 1, and 1, right? So this happens to be row 4 in Pascal's triangle. Okay, and this becomes, there's a generality here that we can see. Okay, so the probability that you select a red marble is 4 out of 7, and the probability that you fail to select a red marble is 3 out of 7. So let's apply that to the probability tree. So let's look at the path with 2 successes. Picking a red marble is a success. So let's take a look at that. So the path here is 4 out of 7, 4 out of 7, 3 out of 7, and 3 out of 7 for the successes and failure. So for every success, the probability of that path is 4 over 7, 4 times 4 over 7 for the successes, and for the failures, 3 over 7. Okay, and that's true for any path with 2 outcomes. It's going to be different, right? So here, look at this outcome, right? This is 3 over 7, 4 over 7, 4 over 7, 3 over 7. So I'll multiply 3 over 7 times 4 over 7 times. So I'm multiplying in different order, but obviously when we multiply, order doesn't matter. And it's going to be the same for any path. So look at this path. It's a different path. It's 4 over 7 times 4 over 7. I think we did the same one, but I already did a different one. We can look at this one. It's actually the opposite. It's 3 over 7 times 3 over 7, right? Instead of 4 over 7, and then 4 over 7 times 4 over 7, right? Anything with 2 successes is going to have these values to multiply to calculate the probability of this outcome of 2 reds. Okay, so probability of 2 reds is this. In any order, it doesn't matter. Okay, and there's 6 of them. So it's times 6. Okay, so the probability of 2 reds is the probability of a red multiplied, to the power of however many successes we're looking for, multiplied by the probability of a failure to the power of the amount of failures we have, multiplied by 4, choose the number of successes. And that's a general formula. Okay, the probability of X successes in N identical independent trials is, and let me explain this to you. So it's N, 4 trials in the previous example, N would have been 4. 2, X is the number of successes. So 4, choose number of successes, multiplied by P. Small p is the probability of a success of an individual trial. So 4 over 7. X is number of successes. Right? Q is defined as 1 minus P. So the probability of failure, not a success. And N minus X is just the remaining trials. That's the number of failures, right? So if it's not a success, it's a failure. Therefore, the total minus successes equals failure. Okay? And that's pretty much it. Each term is the expansion of P plus Q to the power of N, represents the probability of one possible outcome in the probability distribution, right? So when I expand this out, if I have probability of success plus probability of failure to the power of N, each term represents one possible outcome. Anyway, we'll talk about that later. So now, expectation for a binomial distribution. When determining the expectation for a binomial distribution, you can multiply the number of trials by the probability of success in an individual trial instead of using the standard process. Okay? So it's equal to N, number of trials, times the probability of that outcome. And that's all you have to know about binomial distribution. Okay, try these questions 1 to 11 and question 14 on page 168, and that's it for binomial distributions.